Hey everyone, welcome into Unit 6, Day 5 notes. Today we're going to be solving absolute value inequalities. And our goal is that students will be able to solve absolute value inequalities with 80% accuracy. Okay, so let's get started. So use the following steps to solve absolute value problems with inequalities. So we're going to see a lot of familiar steps in solving with absolute value inequalities. But again, inequalities consists of less than, greater than, less than or equal to, or greater than or equal to. So it's going to add a few new pieces of or challenges into solving these equations. So in step one, we are going to isolate the absolute value. Same thing we've been doing. After we isolate the absolute value, we are going to check something. So this is going to be new. So we are going to determine if our absolute value inequality is an and or an or problem. Remember when we did that, right? We graphed and or problems. And we're going to do that using LAGO, L-A-G-O. So what LAGO stands for? We have the L stands for if it's a less than problem, then A means it's going to be an and problem. So after we isolate the absolute value, if we see a less than symbol, it's going to be an and problem. And after we solve the absolute value, after we isolate the absolute value, if we get G for greater than, if we're left with a greater than symbol, the O means it will be an or problem. So that's something you can remember. LAGO will tell you if it's an and or an or problem. So that's our second step, which is something new. And then step 3, we're going to split into two equations, just like we would when solving regular absolute value equations. And then this will look familiar as well. We're going to set up an inequality to a positive solution. And then B, we're going to set up to a negative, which that's not new, but we do need to pay attention to this. When we set up this second situation, we need to flip the sign and then set it equal to a negative. So a lot of little details when solving absolute value inequalities. And just to add on another small reminder or detail, when we work with absolute values, when we work with inequalities and we are dividing or multiplying by a negative number, we need to, again, flip the sign. So it's very important when we're solving these absolute value inequalities, we need to make sure that we are taking our time, and every time we are dividing or multiplying by a negative, that's another instance where we're going to have some change in the problem where we're going to have to flip the sign. So take your time and check for these small details. Okay. So in our first class example, ask yourself, is the absolute value isolated? Is this absolute value isolated? And the answer to this is yes. The absolute value is by itself on the left side of the inequality. There's nothing with it, so it's isolated. Once it's isolated, we go to step 2 and we say, okay, let's use LAGO. And is it a less than for an and problem or a greater than for an or problem? So in this case, this is a greater than symbol, so we will get an or problem. Now the way we're going to show this is when we split to solve, we have x is greater than 2, and then we're going to write or x. And now remember, when we go to this second situation, we need to flip the sign. Sorry, let me actually do that in a different color. So we're going to flip the sign because this is the change that's happening. And then we need to make that +2, -2. And for this example, we are done. Our two solutions in here, and actually, this is one solution together. X can be greater than 2, or x can be less than -2. Okay, let's go ahead to the second example. Ask yourself, is the absolute value isolated? Is this absolute value by itself on the left side of the inequality? And the answer is yes, it is. Now we take a look at the inequality itself. It is a less than or equal to, but less than. So it's going to be an and problem. So we go ahead and we split. We set this one up like normal. We drop the absolute value bars. X plus 3 is less than or equal to 5. And then we used Lago to help us determine it's an and problem. And now we're going to jot down the second version of this, which is going to be x plus 3. And then we flip the sign and make the 5 negative. Again, these small details. And now we can go ahead and solve. So we subtract 3 from both sides. X is less than or equal to 2. And we subtract 3. And x is going to be greater than or equal to -8. So this is all one solution. All right, let's go ahead, take a look at the next one. Ask yourself, is the absolute value isolated? This is the first time where we say no. We have that absolute value of 5x minus 10. So we have to get rid of that minus 10 before we can ask ourselves, is it an and or an or problem using Lago? We cross that off. We have the absolute value of 5x is greater than or equal to 12. Now that the absolute value is isolated, now we can ask ourselves, what type of problem is it? And or? Well, it's a greater than symbol, so it's an or problem. So we're going to split this. 5x is greater than 12. That stays normal. And then we say, or we have 5x. We need to flip the sign to make it a less than or equal to, and then make that 12 negative. Now we go ahead and solve. We divide by 5 on both sides. X is greater than 12 over 5. Or we divide by 5 again. We get x is less than or equal to -12 over 5. Again, this is all one solution. All right, let's take a look at the next example. Ask yourself, is the absolute value isolated? And I have it already circled here. The answer is no. We have plenty of things to do to isolate. First of which is to subtract 8 from both sides. And we are left with 2 times the absolute value of 2x minus 4. Close the absolute value is greater than 2 minus 8 is -6. And actually, I think on your version, this is a minus 2 here. So we need to change that. I need to change that myself to a minus 2. And there we go. Okay, let's continue. So now we have to get rid of that negative 2 by dividing by negative 2. That cancels out. We have the absolute value of 2x minus 4. And now we just divided by a negative 2. So we need to flip the sign. If you worked ahead, you might have skipped past that detail, and we get positive 3. Okay, so we flipped the sign, and actually let's note that. Note that in your notes, right? We have divided by a negative, so we flip the sign. Now we can split because the absolute value is isolated, and we need to ask ourselves, is it an and or an or problem? Well, the sign after we flip is a less than, so it's going to be an and problem. We have 2x minus 4 is less than 3, and we have 2x minus 4. Remember, when we switch over to the negative solution of this, we need to flip the sign again and make it a greater than, and then make that 3 negative. Now we can go ahead and solve. So we add 4 to both sides. 2x is less than 7 divided by 2. We get x is less than 7 over 2, or 7 halves. And then it's an and problem. We need to go ahead, add 4 to both sides. 2x is greater than 1 divided by 2. And we get x is greater than 1 half. So the two solutions we have, x is less than 7 halves and x is greater than 1 half. All right, let's do a few more examples. So number 1 on the back. Is the absolute value isolated? The answer is no. We need to get rid of this 6 on both sides. And I have another error on my page. This should also be a minus sign here. Okay, so that cancels out. We're left with negative 1 times the absolute value of x plus 7 is greater than 1 minus 6 is negative 5. It's still not isolated, right? We have this negative 1 that we have to get rid of. So we divide by negative 1 on both sides. When we do that, cancels out. We're left with the absolute value of x plus 7. And then again, we just divided by a negative. When we divide by a negative, we get a sign flip. So that greater than sign becomes a less than sign. And then negative 5 divided by negative 1 is a positive 5. Now that the absolute value is isolated, Lago, it is a less than sign. So we have another and problem. We split. X plus 7 is less than 5. And, oops, let me do my color coding here. And we have x plus 7. We need to flip the sign, is greater than, and then negative 5. Minus 7 on both sides. X is less than negative 2. And x is greater than negative 12. And there's our solution. Okay, so let's go ahead and take a look at example number 2. Again, ask yourself, is the absolute value isolated? The answer is no. We need to subtract 3 from both sides. And then we are left with 3/4 times the absolute value of negative 6. And then we have is less than 9. We go ahead and multiply by 4 on both sides. We're left with 3 times the absolute value of x minus 6 is less than 36. Divide by 3. Absolute value of x minus 6 is less than 12. Now the absolute value has been isolated, and we go Lago. It is a less than sign again, so it is another and problem. We split. X minus 6 is less than 12, and x minus 6 is, we need a sign flip, greater than negative 12. Hopefully we're starting to get into that routine. We are left with x is less than 18, and x is greater than negative 6. All right, skipping 3 and 4 for now. That's for you all to try. And then here's our last two, 5 and 6. All right, number 5, ask yourself, is the absolute value isolated? The answer is no, it is not. So we need to divide by negative 5 on both sides. Cancels out, x plus 2. And now we need to remember we are dividing by a negative, so we must flip the sign. So that sign becomes a greater than, and then negative 5 divided by negative 5 is positive 1. We go ahead and we split. X plus 2 is greater than 1. And now we check Lago. It is a greater than symbol, so it's going to be an OR problem. So OR, we have x plus 2. And again, when we go to the negative version, we have to flip the sign again. So the greater than becomes a less than, and then the positive 1 becomes a negative 1. All right. Minus 2, minus 2. X is greater than negative 1, or x is less than negative 3. All right. All right, let's go ahead and try number 6, and then you all will try some on your own. For number 6, we ask ourselves, is the absolute value isolated? And it is this time. So we go to Lago, and it's a greater than symbol, so we have another OR problem. We can go ahead right away and split. Negative 3x minus 6 is greater than 3. And we say OR negative 3x minus 6. And again, we need to flip the sign to make it a less than. and make that 3 a -3. And now we can solve. Add 6 to both sides. -3x is greater than 9. Divide by -3. Now this time, we are seeing another sign flip, but it's after we've already done logo, right? Because we are dividing by a -3. So that sign is going to flip, and it's going to become a -3. It's still an OR problem. Add 6 to both sides. -3x is less than 3. Divided by -3. Divided by -3. Again, we are looking at another sign flip because we divided by a negative. So it becomes a greater than symbol. And then this becomes a -1. So that's our solution. X is less than -3 or x is greater than -1. Let's go ahead and jot down this in our notes. So we divide by a negative, so we flip the sign. Oops. Divide by negative right there. Okay, so pause it, try the 4 problems we did not do, come back and see how you did. See you in a few minutes. All right, welcome back. Let's go ahead and take a look at 3. So in number 3, we need to get rid of that 3 in the denominator, so we multiply by 3 on both sides. No sign changing going on because it is a +3. We split, check logo. It is a less than or equal to symbol, so less than indicates an and problem. We go ahead and solve. Again, make sure you are flipping the sign and making your second number negative. And we should get x is less than or equal to 28 and x is greater than or equal to -32. Number 4, we need to subtract that 5, then divide by 2. We are left with a greater than or equal to 6. Greater than would be an OR problem. We split. Again, make sure when you split to that second equation, you flip that sign and make your number negative. All right. Let's go ahead and take a look at number 7. It's not isolated, so we have to add 2 and then multiply by 3 to get rid of the denominator in 1/3. Then we go ahead and we split. It's an and problem because it's a less than symbol. Less than indicates and. And then again, we need to remember that second equation, second inequality, we need to flip the sign and make our answer negative. And for number 8, we need to subtract that 11, and it gives us a -2, but then we need to divide by a -1. So we are getting a sign flip here because we are dividing by a negative. Then that makes it a greater than or equal to sign, greater than, telling us it's an OR problem. And then again, last time here for the notes, when we split to that second equation, we need to flip the sign and make our answer negative before we solve. Okay, there you have it. A lot of little details to pay attention to when solving absolute value inequalities. Please make sure you check through your work thoroughly and check through my work thoroughly. And please reach out to your teachers if you have any questions. Thank you all for stopping by. Hope you have a great rest of your day. Peace out.